proposal is simply to conduct a Michelson-Morley type experiment in low Earth orbit. We're predicting that, in contradiction to special relativity, which would predict essentially the same results as a terrestrial version of the experiment, essentially null results. We're predicting that a result equivalent to the orbital velocity of a spacecraft for low Earth orbit. That's about 7,600 meters per second for a 500 kilometer altitude orbit, typical orbit. And if it was launched into interplanetary space, essentially between the Earth and Mars, has to be fairly far away from the Earth, maybe at least 2 million kilometers or so. It would detect the full orbital solar orbit velocity of the spacecraft, which would be around 30,000 meters per second, and which is the velocity that was sought by almost all the early Michelson-Morley type experiments and was not detected. Like I said, this is not a new idea. It's been proposed before. There's actually a letter published in 1986 by two mainstream physicists proposing it, but it's essentially ignored. It's because, like I said, the mainstream physics community predicts or would predict that it would just have the same null results of terrestrial-based MS or Michelson-Morley experiment. So the previous proposals have been essentially ignored because they would consider it a waste of time, even though it wouldn't be that difficult to do. But the previous proposals generally just said, hey, it's a good idea, let's try it. They didn't really just said, hey, it's a good idea, let's try it. They didn't really have any evidence to suggest that it could succeed or would succeed to have a positive result. So we're saying here that there actually is evidence that it should have a positive result, basically based on first order phenomenon with light propagation, EM wave propagation, such as there's a thing called the pseudo range correction that's used by GPS receivers, because the transmission time of a GPS pulse is affected by the rotation pulse, is affected by the rotation of the Earth. So a receiver that's rotating with the Earth, on the Earth, after the GPS transmits its location signal, moves away from the GPS satellite, it takes longer for the pulse to reach the receiver, that location, which is typically for 40 degree latitude, around 360 meters per second, which is much slower than an orbiting satellite, low Earth orbit MMX or solar orbiting MMX would detect, would be running at. Orbiting MMX would detect, would be running at. The pseudo range correction that's part of the GPS standard for calculating location essentially is based on the notion that the Earth is rotating with respect to the Earth centered frame, and that's affecting the transmission time. Essentially is the same as equivalent to an ether wind of that velocity. The second point I'd like to make is that MMX type experiments that have been conducted since 1979 have shown a possible detection of this much lower velocity or ether wind, but they typically dismiss it as noise because it is such a weak signal, because the Michelson-Morley interferometer is essentially what's called a second order light transmission phenomenon, because of the reflections from the mirrors, which means that the strength of the signal is based on velocity squared over c squared. So a velocity squared over c squared. So a signal that's 1/1000th or a velocity that's 1/1000th of the expected velocity would actually be a millionth of the strength of of the magnitude of a higher velocity. Let's say the velocity is 100 or so. The strength of the signal would be 1/10,000th of what's expected. And MMX conducted in outer space may actually be the only way to provide a unambiguous measurement of a velocity with respect to the interferometer. Because the velocity of the spacecraft would be 22 times the velocity of the rotation of the Earth, which would be a 440 times larger signal, which would be much easier to detect. So if it is detected, the negative result, the null result, was not really true. It was just that it was much smaller than what they thought they were looking for. And as we all know, most, if not all, or I should say the great majority of mainstream and dissident physicists, physics community, almost unanimously assumes that if there is an ether, it's what's called the universal. It's the same everywhere in the universe, not moving, not different density, just homogeneous and isotropic. So we're saying here that that's not, we're ether model essentially, that that there's a I'll go on from there. What we're trying to show essentially is that the velocity of the receiver is not independent of with respect to any reference. We're saying that the ECI is actually Earth Centered Inertial Reference Frame, also called ECI, is the preferred reference frame for light propagation in the vicinity of the Earth. If you go far enough away, you actually switch to the solar inertial alternative ether model. So that's why we really need to do this experiment, because we can't get a high enough velocity to detect unambiguously on the Earth, but it would be a lot easier and to detect when the velocity of the spacecraft is the actual velocity that you're trying to detect with respect to the Earth-centered geocentric reference frame. So we go back again to three possibilities for why MMX experiments to date have had null results. The first one, and obviously the one that's it's been accepted since 1905, is that there is no ether. No velocity could be measured, no matter how precise and sensitive your interferometer was. Another possibility is that the interferometer is conceptually not capable of detecting a velocity, even if there was one, and capable of detecting a velocity, even if there was one. And that's sort of what the Lorentz-Fitzgerald contraction and the Lorentz transformation were invented to explain this, the null result. There's a third possibility that I've rarely seen mentioned, velocity, and that velocity is the Earth's rotation velocity, and that's too low to be detected unambiguously by even the most sensitive Michelson-Morley experiments that have been conducted to date. And that's what I'm claiming here is why there's been a null result, and why doing it in outer space, would have a positive result, because the velocity with respect to the ECI, as I said, that GPS is telling us, then the velocity to detect would be, or the magnitude of the effect would be much higher. Or a different alternative model of the ether that was first proposed by Peter Beckmann in 1986 in his book Einstein Plus 2, and essentially what led to the formation of this organization, and also by a deceased professor of electrical engineering in Taiwan, whose name was Ching-chuan, who independently came up with virtually the same ether model. And as I already mentioned, the GPS pseudo-range correction is almost a classical interpretation of that, is that the velocity of the receiver is effective speed of the microwave pulse, because the transmission time takes longer, because the receiver is moved from the time that the pulse is emitted to the time that it's received. An extra distance of approximately B over C squared, where again, v is the velocity of the receiver with respect to the ECI, and that due to the rotation of the Earth. Or if there's say a jet that's got a GPS receiver, you would add or subtract the velocity of the jet to velocity toward or away from the satellite. So, and as I also mentioned already, that experiments from 1979 to the present have possibly detected this velocity with their much more sensitive versions of Michelson-Morley experiments. The first was done in 1979 by Brie and Hall. And instead of using mirrors, they used what's called a Fabry-Perot epsilon and lasers, and were able to achieve a much higher sensitivity. But they were looking for essentially a Lorentz invariance violation due to some new physics theories at the time called standard model extension, some other pretty wild stuff. And they saw a signal that was essentially occurring at a frequency that was twice the rotation rate of their interferometer, because they had their interferometer on a turning platform with a vertical axis, like the original Michelson-Morley, and that's totally consistent with the Earth's velocity due to the Earth's rotation. And they also had included data in their report where they called this signal spurious, but some have analyzed it particularly Professor Howard Hayden, the emeritus of the University of Connecticut, I guess the same place where we had the last 2018 CNPS conference was held. And he looked at the data, he looked at their report, 2 omega, he called it signal, and he also noticed that the phase of the signal, the direction that it was pointing at, was constant, which would also be consistent with a velocity due only to the Earth's rotation. And the magnitude of the signal was maybe twice or half, I forget. But there wasn't really enough data to make a firm, unambiguous conclusion that in fact, the third characteristic, or I guess essentially the fourth characteristic of the signal would be that it would point directly. It would point directly to the east-west. The direction of the signal would be east-west, so the peaks would correspond to that compass direction. But apparently, the experimenters did not record that value, how their experiment was oriented. So he wasn't able to make that conclusion. And as I said, that the signal was weak enough that it could be considered mathematics, I want to call it. So it wasn't an unambiguous detection, essentially. And there have been actually some other even more sensitive experiments, Michelson-Morley implementations over the past 20 years, again looking for these Lorentz invariance violations and standard model exception parameters, completely ignoring the possibility of a velocity, and they also dismissed. They also appear to have detected this 2 omega, twice the rotation rate of the turntable signal, and also dismissed its schematics. And again, it was weak enough; it could be ignored, essentially, or declared to be just noise. The fourth, what I was going to say is that even the most recent and most sensitive experiment in 2015 reported this 2 omega signal, but they declared that it was probably due to interaction of the turntable with the Earth's magnetic field. So who knows? Sure. That's why we need to do this experiment in outer space, because it would give a clear yes or no answer, in my opinion. How are we doing on time? These recent experiments were used what's called cavity resonators, and it might even be, and they were looking for frequency variations, not phase or fringe. And they were looking for frequency variations, not phase or fringe shift changes, like the traditional mirror-based Michelson-Morley experiments. So there, just to as an aside here, that an MMX experiment in outer space, low Earth orbit or solar orbit, since there would be no vibration from people walking on the sidewalk to cause fluctuations. It's a great vacuum, so you can have, you won't have to struggle with air currents, temperature gradients, although you might want to shield it from the sun, from sunlight. And also, because it's in microgravity, it would be very easy to orient it in any direction you want and give it any rotation about any axis that you want. So you can try all sorts of possibilities there. You could even point it at the CMBR dipole, which is supposedly in the constellation Leo. 7 hours right ascension and 6 degrees declination, which is what some have tried to claim that they've been able to detect velocity with terrestrial experiments. So it'd be a good experiment to try even just for that reason. So what is all this based on? It's based on this. What is all this based on? It's based on this what I call and what ching-chuan called the local ether model. Essentially, that the ether has a variable density that's proportional to the local gravitational potential generated by is denser near the surface of the body, and gets weaker the farther away you get until you reach a boundary where the local ether of a larger body becomes dominant, and essentially you switch reference frames. The larger body, such as the sun. So we're estimating that it's about the same distance. The transition distance is probably about the same as the L1 or L2 Lagrange points. Gravitational force no longer points at the Earth, points towards the sun, and that's about roughly a million kilometers in the center of the Earth, well past the distance to the moon of 300 odd kilometers, 300,000 odd kilometers. So this looks like a halo. It's kind of similar to a halo in a lot of ways because its density varies, and there's two main postulates for this. That this halo is at rest with the Earth Centered Inertial reference frame, or for the sun would be the Sun Centered Inertial reference. It doesn't rotate. It always points in the same direction in the sky, just like so. Here's a rough diagram of Sue's model. You can see the Earth here surrounded by its local halo of ether, and so this halo is carried with the Earth in its orbit, but the Earth rotates inside it, sort of like as Peter Beckman put it, like a woman in a hoop skirt doing a spin, but the hoop skirt is not attached to her, so she spins, but the hoop skirt doesn't. And you can see that here's Jupiter. It has her halo because its strong entire mass, so it extends out further to where the sun takes over, and then the solar system, maybe out to 2 light years of the sun, has the sun's local, and then the galaxy's local ether eventually becomes dominant Milky Way galaxy. So I'm hoping some people have some questions about this local ether. I'm glad to explain it more, but I think I'm going to just go on to some practical considerations of how to get this experiment accomplished. So the general physics community believes that it's a waste of time, and essentially even ignores space agencies like NASA also ignore proposals. And probably even other nations' space agencies would too. No one would dare sponsor this mission or project for fear of being ridiculed. But a privately funded project, I think, is now conceivable because there are now private companies that will launch a spacecraft for you as long as you pay them the money. They hopefully are not going to care too much about whether the nature of what you're launching is not going to cause a problem. And one such company is called Rocket Lab, which actually I just saw today. They had their 7th successful orbital launch. So they actually have rockets that can put a small spacecraft into orbit. There's also now a technology called Cubesat into orbit. There's also now a technology called Cubesat, which essentially allows you to build a satellite out of a tiny satellite, like a couple of kilograms, out of off-the-shelf components, and have most of the pieces that you need to have a working satellite. And their standard rocket also supports multiple different projects to share a launch. So you only have to pay for part of the launch cost, which could be as low as $500,000, which is not peanuts, but not billions either. So hope now is that Rocket Lab is advertising a service to essentially build your satellite for you, design it and build it, and provide the common components that you need for a satellite, like the control and communications, power and thrust, and hopefully, I guess, gyro to power and thrust, and hopefully, I guess, gyro to maintain orbit position. So I'm making a super wild ass guess here that you could do the whole project for, say, under $2 million, in which case, and that brings it down to a range where it used to be $10 million just to approach a space launch company with a proposal to launch a satellite. So it's a lot cheaper now, is my point. And even more important, you don't have to pass a committee that's going to probably not even consider your proposal once they know what it is. Funding as a possibility to at least raise part of the money and maybe convince a wealthy donor to help out. So assuming we could get the project into space and it does detect this approximately 7,600 meters per second velocity, then you might be able to convince National Space Agency to replicate it. So because just one private company doing this, they're going to probably ignore it or think it's just a mistake, an error, deny it. But if you can get some other more reputable, more credentialed, maybe universities to do the replication, then more people might take notice. And getting funding for the interplanetary becomes a lot more likely. Sponsorship proposal. So, in conclusion, I reiterate that conducting an MMX in outer space might be considered high risk, but it has the potential of a very high impact/reward, which would be to overturn Einstein's relativity. And it wouldn't just be special relativity, because as Einstein said, general relativity is general special relativity. And he said that if it's like a house, if the first floor caves in, then the second floor will also. I believe I found that quote somewhere. Similar quote. So let's say we do succeed and the whole question of special relativity is brought into question. Then you're going to want a replacement model. And I'm proposing that the Beckman-Su local ether model is a candidate to replace Einstein's relativity. It's obviously not fully developed, but there are a lot of phenomena that hasn't been explained. It's essentially two individuals, but it would put physics back in the right track, and other people could extend it and apply it to other phenomena. And so my final point here is that billions have been spent on unsuccessful attempts to detect hypothetical dark matter particles. So why not try this experiment? It could be done for probably a few, which is a lot potentially more useful. Oh yeah, and by the way, one more little kicker here is that this local ether sounds a lot to me like it could be the substance of dark matter. It's not these exotic particles. The proposal is simply to conduct a Michelson-Morley type experiment in low Earth orbit. We're predicting that in contradiction to special relativity, which